Today we're going to be talking about the depreciated cost method of supporting adjustments. And I'm going to start in standard one, real property appraisal development in USPAP, where it says we are to be aware of, first of all, an appraiser must, that's a big word, be aware of, understand, and correctly employ those recognized methods and techniques that are necessary to produce a credible appraisal. Now, the recognized methods are not contained in USPAP. They are contained in a book called The Appraisal of Real Estate, 15th edition, among other sources. But what the appraisal of real estate talks about is paired data analysis. We think of that as paired sales. Group data, groups of sales. Secondary data, which is survey data typically. Statistical analysis, including graphics, and we'll be talking a little bit about that. And then my favorite, cost-related adjustments, specifically depreciated cost, because I think that is the fastest way to get market-supported adjustments for probably half the grid. It's the bottom half of the grid is primarily cost-related adjustments. It's very clean data. I'm going to switch over to the cost table. This is 2023 cost data from National Building Cost. And I should mention that we're going to be cutting over to the 2024 data relatively soon. There's no need for you to do anything. We'll just make the announcement and cut over to the 2024 data. But here's a table that shows 6 quality ratings, which align, I think, perfectly with the UAD system. So if we look at the Q4 right here, that means good standard in the language of National Building Cost. A 700 square foot amount of GLA costs $183.59 per square foot. And if we follow that along to the right, as the house gets larger, the cost per foot goes down. Can pick that up here at 2,200 square feet. It's going down, down, down until we get to 5,000 feet, which is the end of the table. Now, I think it's helpful to see what happens to total cost. So to do that, I've got the average cost in the column here next to the 700 square feet. Notice 183.59 all the way down to that 119.72. If you're an Excel user, you'll understand this. This is one of my favorite parts of Excel is that you can autofill an equation. This C5 times D5 will become C6 times D6 all the way down. If I just double click on this lower fill handle, it's called. So there's the total cost going up as the quantity goes up, the number of square feet, but the cost per foot was going down. And there's a mathematical relationship shown on this chart. This is a scatter plot that shows, of course, the top price up here, the top cost per total cost, and then here's the top size, 5,000. So that lines up. The dots are the data points. That's where each of these intersect. The line of best fit is included because I've built this to include the equation of the line. Y equals, let's call that 110 times the number of feet plus $56,000 is the total cost of GLA. That's the equation for that line. That makes things a lot easier for us. The R square, that's called the coefficient of determination. Notice that is very close to 1. R square is always between 0 and 1, and 1 means 100%. So here we are at 99.98%. And what that means is 100% of the change in total cost is due to the change in the size of the house, which makes sense when it's a straight line and when it's cost data. But that same idea carries through later on in other calculators. Now, a Q4, according to National Building Cost, they start with an assumption of a quality of a Q4. They call it good standard. They assume that that's a 60-year life, economic life of that building. Now, the effective age, I've just got an example in here of 18 years. that would mean 30% depreciation, right? So there's $110 per foot cost right up here for a GLA. If the market sees 30% depreciation, that means the market is showing a contributory value percentage of 70%. So 18 divided by 60, that's the 30%. 42 divided by 60, that's the contributory value percentage. And in this case, the GLA adjustment calculated in this way is $77 per square foot. And here's a little quote from the Appraisal of Real Estate. In applying the concepts of economic life, effective age, and remaining economic life, appraisers consider all elements of depreciation in one calculation. So depreciation includes physical, functional, and external. There are calculators out there that use only physical to calculate effective age, and I think that can be a problem, not necessarily, but I prefer to extract depreciation from the market by doing the cost approach. I like to use this example. On the left, that represents a $450,000 market value. The buyer and the seller, both agents, even the county recorder, agree that that particular house is worth $450,000 market value. Now, when you get an appraiser involved, they'll recognize right away that there's land. So let's look at this bottom. It's a constant. $100,000 is the total of site plus site improvements, just to make the math easy. It's a total of $100,000. So the contributory value of the house to this parcel is $350,000. Now, if you go to the next step and do the cost approach, you would find in this case that the cost to build that house, replacement cost new in today's market, is $500,000. So we can see that land plus the cost exceeds the value. And that means there is depreciation. So here's the $150,000 depreciation. This part of this stacked bar chart or column chart shows that depreciated cost is $350,000. That's what we name that. And you can see in this context anyway, that contributory value and depreciated costs mean the same thing. Now, again, the reason I think depreciated cost is a good place to start is because we can do adjustments for cost-related features like bathrooms, GLA, basement finish, basement size, garage stalls, porch, patio, deck, that type of thing. And what that'll do, it'll give us adjusted sale prices that we can use later on. We're not going to be talking about that today, but you can use these adjusted sale prices to develop adjustments for things that are not related to cost, like site and view, that kind of a thing. So when we know adjusted sale price, then we can calculate the top half of the grid. So at this point, I want to open Solomon. Now there's a lot of resources here. If you want to see a video that contains everything from front to back, beginning to end, click here. That video has bookmarks. It's a total of 32 minutes, but there are bookmarks so you can see every calculator explained and skip around to find the help that you need. Under resources, there are other training videos linked. There are links such as other webinars we've done. Here's a link to repair and remodeling costs if you're needing to do remodeling in a Q4, or excuse me, a C4 or C5. Here's lifespan of components, and then here's a study about cost of construction. There are also downloads. One of them is recommended commentary. How do you explain the adjustments that you're making with the Solomon calculators? It'll explain depreciated cost plus the other methods. But now I'm going to go log in. So now I've found my way to a secure website that's hosted on a web server. And if I can log in with my email and last name. And we're going to concentrate on this application today because this is the way that you would extract depreciation from the market. And when you've extracted depreciation from the market, that makes depreciated cost adjustments market-based, right? That's just simple logic. So let's say we have a market value of $450,000. And let's say that we've got a site value of $80,000. Site improvements are $20,000. And this is an example. I can show you how to find information about that over here. And let's say the zip code has, we're going to use the word base, meaning the base cost across the country. The way cost data is developed is they use a base cost, and then they increase or decrease by a percentage depending on the local labor market and material market. I'm going to say quality rating on this is 4, and that there's 2,800 square feet of GLA. It has central air and a 1,400 square foot basement. Basement finish is 800 square feet. And we're going to add a basement bathroom. Now, the reason we ask for the basement bathroom count is because the numbers that we use from National Building Cost do not include bathrooms in the basement finish numbers. They do include bathrooms in the GLA numbers. And let's say we have one fireplace and a deck, 200 square feet. Wait a minute, covered porch. And a 600 square foot garage. So that's all you need to do the cost approach. You can see that the site value was up here at the top, right where it belongs on page 3 of the 1004, and then site improvements, and then the market value estimate is not something that we're going to calculate from the cost approach. We're going to use a market value estimate to calculate depreciation. In my brain, it's easier to estimate a market value. For instance, this could be a comparable that already sold, and you're just trying to figure out what the depreciation is in the market. It could be the subject. If you've looked at a property on paper and you've chosen comparables and you've driven past those comparables and then you've inspected the subject, by the time you get home and you've drawn your sketch and you've looked at interior photos of the comparables, you should have a pretty good idea what the value is going to work toward. So this is, I think of as in the scientific method, that is a hypothesis. And just a quick word about the scientific method. And this is, I've changed the words a little bit to reflect what we do as appraisers, but we start with a value question, then we make observations, and that is the idea of driving by the comparables to see how they're set on the lot and so on. And we measure the subject, we take interior photos, we go back to our desk, and we look at the interior photos, and by that time, we're ready to develop a hypothesis of value. That's that 450 in this case. In science, we always test the hypothesis. Science is kind of an organized, skeptical method, right? We don't want to bring assumptions to it. We want to learn from the data. So we test our hypothesis in the grid. And if the hypothesis is correct, in other words, if it's pretty close to 450, we'd go ahead and do the report. If it was incorrect, then we'd revise the hypothesis. So that's my take on the scientific method. When I click calculate, all of these areas that we've noted over here become total cost. The dwelling is 381,204. That's 2,800 square feet times the cost per foot. And you can see here that that's 136.14 that you could use on page 3 of the 1004. The basement is 51.54 per foot, totaling 72,152. The additional features refer to fireplace, deck, all the porch varieties. and that in this case is $14,242. The garage, 32,453, that's 5,409 per square foot. And when you total up all of these costs, you end up with a total estimate of cost new at $500,000. Now, excuse me, the depreciated cost, as we just talked about in that graph before, that bar chart or column chart, I guess it was, market value minus site value minus site improvements is $350,000. That's the contributory value of the house. So there it is. Depreciated cost is the same as contributory value. If we do some math and divide the total depreciation by the total cost, that gives us 30%, correct? 150 divided by 500. There's our 30% depreciation. If we subtract 30% from 100, that means there's 70% contributory value. The market's paying 70% of the cost for the house, and that's a market supported percentage. And then if we take this 30%, according to the equations of the age life method, 30% of 60, which is an assumption of economic life, that means effective age is 18. And remaining economic life would then be 42. So 30% is the depreciation percentage. The market's paying 70% of cost. The default adjustments that I have here mean that 70% of the cost of one more square foot is $77. 70% of the cost of one more basement foot is $15. Same with basement finish, all the way down. The 70% of the cost of a deck is $24. Now, the reason that we've included this second column, I call this percent of economic life. A deck only has about a third of the life of the house as a whole, right? The house has a 60-year economic life. The deck has a 20-year life. And by the way, that is in data that you can download on that website that I showed you before from National Association of Home Builders. So now when I click calibrate, that's my term for trying to bring these depreciated cost numbers closer to reality based on the idea that some parts of the house depreciate faster than others. Okay. Now, an example of functional depreciation, I use 50% for the fireplace. And that's just a percentage I've learned in my market. That would represent 70% of the cost of the first fireplace. And then I multiply that by 0.5 to get the value of a second fireplace. And that reflects functional depreciation in my view, and I've seen it in the market. People will pay the full depreciated cost for a fireplace in essence, but the second fireplace is worth less. You can use 100% if you'd like. You could use 60, 20, you could use 0, whatever you think reflects your market. I typically use 50. The same with the bathrooms. I make 50% here so that when I click calibrate, I've got the above grade bath over here and the below grade bath over here. Below grade bathrooms, I think, are worth about half as what they are on the main floor. And then the other one I typically start with is 50% for basement finish. And when I click calibrate, that's why I think a basement finish adjustment is $13. A basement bath is $3,800. Basement size, I don't believe depreciates at all. It's always going to be there, right? It just is holding up the rest of the house. So $15 for basement size. And then GLA, it depends on your experience and what you've seen in the market. There are other ways to do a GLA adjustment. Some people look at this situation and realize that, well, if we've got 18 years of effective age and a roof only lasts 20 years, the roof is pretty much, it doesn't need to be replaced to sell the house, but it's just part of the overall condition. Things are wearing out a little bit. Carpet and paint only have a 10-year life. Furnaces and water heaters are 10 or 15, and a furnace might be 30 nowadays. But if you add all those up together, you might end up with something like, this is a survey result actually of Solomon users, 63%. So in that case, the GLA adjustment would be 48. There's other ways to do that in Solomon. We're not going to talk about that today, because this is purely depreciated cost. Now, the reason that this is important, again, is because you're extracting effective age from site value, cost, and market value. If you are going through this process and you use these adjustment numbers in your grid, and this is that last part of the scientific method, right? Where if the hypothesis is wrong, let's say that this ends up being closer to 460. What that means is we're going to have less depreciation. So depreciation went from 150 down to 140. And that means we have a different effective age, lower effective age. We have higher remaining life. The market's paying a little bit more as a percent of its cost. And now we've got a little bit higher adjustments. So it's an iteration process, I believe, to go through that you can use to support several assignment results. Remember, we're supposed to support effective age. Effective age is more than just physical depreciation. So I think the cost approach is the place to do that. So again, in the grid, if we've solved these adjustments with depreciated cost, then we have a basis to use these adjusted sale prices to do sensitivity analysis to solve for these. And we'll be talking about that not this week, but in a couple of weeks from now when we're talking about sensitivity analysis. Now, another important thing, cost data, again, it's base cost. The base cost is modified according to the data publisher for zip codes. They call them area modification factors. So this region of zip codes, 553 to 555, so anything in between there, 55310 to 5599, has a 13% modification above cost. So there's 13% higher cost in this zone compared to the country as a whole. And then they have something called other factors. So for instance, a repetitive build is a cost savings, right? If you're building in a subdivision, just going from one house to the next with the same crews, you can save quite a bit of money. That's why developments are probably the best way to get housing ownership for the most people. So other factors, the example here, repetitive builds is 9%, minus 9%. So I'm going to go back to Solomon at this point, and I'm going to use the zip code 55112. I think that's a real zip code in Minneapolis. And I'm going to use -9 for the area, or for the modification for the multiple builds. So let's say we're in a subdivision in a suburb of Minneapolis, and it changes the numbers a little bit. Effective age is back to 18, remaining life is 42. So that's where the factors are used. Factor is another way of saying a factor of 1 is 1%. And then the zip code 55112, I think that it's probably different than 13 because that was this year's data. It might have been 10 back then. But that's Solomon cost. I think it's the most important tool we have to get you further into the development process when you're working on an appraisal assignment. If you want to get a hold of me, here's my contact information. I'm up in Minnesota where we do have basements, and it's getting cold now. But finished basements are a big factor up here. I wish I was in Las Vegas or Miami where there were no basements this time of year, but I guess we grow to love kind of where we're from. So use that email address to get a hold of me. I'm happy to do one-on-one question and answer periods. Again, I like to refer you if you're a little bit shy and you just want to consume the information this way, SolomonAppraisal.com or the Solomon Adjustment Calculator. Here's the video that takes you through everything from beginning to end. I should have showed you too, in the actual tool, there's a user manual that does pretty much everything that's in the video. It takes you step by step through each of the calculators. Today we talked about Solomon cost, starting on page 8. It looks like it goes 4 pages. But you can open this, and it will take you through everything from beginning to end. And at the end of each chapter, it does talk about explaining your adjustments. So for for depreciated cost, I say adjustments for building characteristics are developed with the depreciated cost method. See page 3, adjustment calculations, and my page 3, you can see in the recommended commentary. And then the depreciated cost adjustment summary attached. Now, I take a screenshot instead of using the report. I mean, if we go over here, you can see that you can print the report, keep in your work file, or put in Dropbox. It is general here. It tells you as an example, these are the real numbers, but these examples do not have the same numbers that correlate with these. These are just examples. I prefer a screenshot. I just take a screenshot of this, and then I put it in my report as my support for the cost-related categories. So thank you for your time today. You're always welcome to get a hold of me. Next week is going to be a little bit difficult. I'm actually going to be speaking in Utah at the Utah Assessors School. We've got a Solomon fan out in Utah who is in charge of training appraisers for the state of Utah, and he wants to have me present depreciated cost and some of the other tools we use at Solomon. So we'll do this again tomorrow and also Thursday. And there will be a recording that we'll be sending out. We'll pick the best of the 3 for a recording. So you can consume that, or again, go back to that video, which is probably better produced than me rambling on live. So thanks again for your time.